Hey guys, it's Mr. Calderon with Queen My Pawn. I'll be talking about inverse functions, what they are, what they represent in this video. I'll begin by sharing my screen. So from where I live, if you want to get to FIU, you have to take a bus. And let's say that bus is called, the buses, they have different names, they have letters, they have numbers. Let's say a common route from, for example, Brickell to FIU, it's the 8 bus. So right here, there are locations. And let's say this location right here, this little dot, let's say it's Brickell. Okay, Brickell is near downtown. Now, the bus will take yourself from Brickell, this location, into other locations, namely FIU. Okay, so we can call this right here FIU, that other little dot. So this is the start. This big potato-shaped thing represents your starting location, and this other potato represents the end. Okay, so this right here, it's basically the route the bus takes. Okay, so in this case, it would be called the 8 bus, and the 8 takes in your location. Let's say I'll call it S. Okay, S for start. The 8 takes your location and takes you to FIU. So now, if you want to get to from FIU to Brickell, you just take the 8, but this time the 8's going backward. So from FIU to Brickell, you would say, oh, I'm taking the 8, but I'll put -1 for backwards. And this time you put E for end. Okay, you take the end location with the bus going backwards and you end up at Brickell again. Okay, so check it out. If you start off at this location, S, actually I'm gonna write it in red. If you start off at Brickell, their starting location, and you take the 8, then this right here represents FIU. Okay, after all, FIU is the 8 taking you from your starting location over to FIU. And then this right here represents FIU. So if you want to take the bus back to Brickell, you have to take the 8 backwards. So as you can see, you get this as the representation, the total representation right here. And that'll just equal your starting location. One more time, you start off here at S, then you take the 8 to FIU. At FIU, you want to go back because you're done studying or working or whatever. You have to take the 8 backwards for that. This 8 backwards will take you from FIU back to your starting location. And basically, as you can see, this is what inverse functions represent, where buses are the functions themselves. Functions map you from one place to another. That's literally the mathematical definition. And from what you can see here, you could just cancel out the 8 and 8 backwards and you just get S right here. And guess what? That works in math too. What I just described was a real life application of it. So let's refresh. And let's say that I have something like 3, okay? Now 3 to 15, I wonder what bus I have to take. Actually, there's 2 buses I could take. For example, I could take the +12 bus and it'll take me to 15. And if I want to go backwards, I take the opposite of addition, which is subtraction, the -12 bus. Okay, it's a 12. Just one of them's going one way and the other one's going the other way. Okay. The other one could have been times 5. And going backwards would be divided by 5. Now, there is actually a way to represent inverse functions in math. Let's say that I have y equals x squared. Well, here's how you do it, okay? First step, switch the x and the y. So instead, I'll have x equal y squared. There you go. I've switched the x and the y. Next, I solve for y, okay? By doing that, I have to do SAM depth backwards, and all I have to do is a simple square root. Oops, too high. And the roots and the square cancel out, and I just get y equals the square root of x. Great, let's look at what that looks like, by the way. So that's my original function, and then I have the square root of x represented as 0.5. That's what it really is. And as you can see, we're not going to look at this left half, and I'll tell you why in a moment, but let's look at this half. You can see that along the line y equals x, it's a mirror reflection. This point, let's say 2, 4 is reflected onto the blue line as 4, 2. They switch places because that's exactly what we did when we tried to find the inverse. We switched the x and y. That's how it's done in math. And there's many inverse functions, okay? Now, let's say I have another function like 2 to the x. Well, 2 to the x is an exponential function. Turns out that the inverse is called logarithm, okay? It means ratio of numbers. And why is it called ratio of numbers? Because, well, let's say that I have x and y. I have 1, 2, 3, and let's say that y is 10 to the x, an exponential function. Then, you have 10 here, 100 here, and then 1,000, right? It's going up by a factor of 10. But now let's say that I have instead y equals log of x, which is the inverse. It's defined to be the inverse. So that means that x and y switch places, which means that when x is 10, y is 1. When x is 100, y is 2. When x is 1,000, y is 3. You can see that the columns switch places, and that's why it's called a ratio of numbers, because x is going up by a factor of 10, but y is only going up by 1. So that's why it's a ratio. It's like 10 to 1, and that's exactly what's going on. Okay. 102, well, that's 10 to the power of 2, which is 100. So it's still going up by a factor of 10. We can take a look at the graphs over here. Let's say that I have 10 to the x, and here I have log of x. And you can see they're mirror images, okay? And this time they really are mirror images. But in my other one, let's see. Now, I want to talk about why this half doesn't pop up. It's because when you take x here is -2, right? And then you have the square root. You have -2 squared is 4. But then when you take the square root at 4, you can only have a positive number. You can't have a negative number. You can't have a -2. So that is completely chopped off. And that's why we have to restrict the inverse, okay? So, back to this. The inverse of 2 to the x is log of x, but here the base is going to be 2. So let's say that I have location 5. I'm at 5 right now, okay? 5 is a place on the earth. And let's say I take the exponent bus. So, okay, great. It'll take me to 32, right? But then I put log of base 2. I put that way too high. I put log of base 2 right here. Well, let's see what happens. So 2 to the 5th power is 32, and let's see what happens when I put log of 2. Log of 32 with base 2, I mean. Oh, look, I get 5, the exact same location. That's what I've been trying to say the whole time. log and exponents are inverses. In fact, you can just cancel them out with an upside down rainbow and you just get the original location. Excuse me. So that's a brief introduction to logarithms. Okay, I might as well just merge these videos together, but now we've introduced the inverse of exponents. So that's also a brief introduction in general to inverses. It applies towards all mathematical functions. So there's a lot more to say about inverses, but that's all you need to know for now. Make sure to like the video if it was helpful. Comment if you still have any more questions. Make sure to subscribe by clicking the red button, and I'll see you on the next one.